So first of all, welcome everyone. My name is César Luaces from ANEFA, the Spanish Aggregate Association. I'm coordinator of several projects, European projects. I would like, first of all, thank Aggregate Europe, UEPG, for hosting us in this clustering meeting here in Brussels. I will also would like to thank Susana Xará from the European Commission, from HaDEA, that is the granting authority of the 5 projects. She will be moderating this panel discussion. And I just want to say that what you have in the screen is the logo that we have been we produced for the 5 projects that are participating now in this clustering event. So I thank you for attending this clustering meeting, and I will give the floor to Susana Xará that will be coordinating us during this session.
Thank you very much, César, and thank you very much for the invitation, and also to the coordinator of this cluster for putting together these very, very interesting 5 projects that found some synergies and are looking forward to the development of Europe. So it is very good that you were able to find these synergies between the different projects. So for this session, we will have 5 panelists representing the different projects that are in this cluster. We will have Stefania Vitale from Passenger, Ana Maria Martínez from Reproduce, Carlos Fernando Forero for Rotate, César Luaces representing the project Simin CRM, and José Eugênio Ortiz representing the DigiEcoQuarry, that is in fact the organizer of this very interesting event. So as César said, I'm working for HaDEA, the granting authority of these projects, where I am a project advisor, and some of my other colleagues are the project advisor of a few projects that are also representing here. So we will start now with a small introduction about each of the participants representing each project. And I would like to ask each of you to present your viewpoint about the current situation in this field and the connection of your project to the topic. So it is an open question. You can address the most important aspects that you see in relation to the subject of the materials that you are working on. You can address your concerns or the best things that you found, so it's up to you. You have 3 to 4 minutes each to present those aspects. And I will start with the first panelist, that is Stefania Vitale, representing the project Passenger. So Stefania is a materials chemist. She holds a PhD in chemistry from the University of Catania in Italy, with a solid background in material chemistry and extensive expertise in nanomaterials and surface engineering. She is currently Science Officer at European Science Foundation, where she leads the Material Science Cluster. She is involved in several EU-funded projects in the field of, in the field of material science, where she participates in management, coordination, and dissemination activities. So, Stefania, thank you very much for representing this project Passenger. And please, your opening statement. The from 3 to 4 minutes maximum.
Yeah, thank you very much for the kind introduction. So I'm here today on behalf of Passenger, of which I'm responsible for dissemination and communication. So Passenger is a EU-funded project under Horizon 2020, implemented by a consortium of 20 partners, coordinated by HaDEA Nanoscience. The main challenge that Passenger is addressing is finding alternatives to rare earth elements for the production of permanent magnets. So why permanent magnets? Permanent magnets are nowadays key to many strategic technologies, going from electric mobility to wind turbines and aerospace. And why are these technologies strategic? They are strategic for Europe to reach the digital and green transition, as well as to meet the objectives of the Green Deal. Key components of permanent magnets are rare earth elements, and rare earth elements are associated to a number of issues. The most important for Europe is that to cover the demand for rare earth elements needed for the production of permanent magnets, we rely nowadays almost entirely on imports from overseas countries, which of course exposes us to a high risk of a supply crisis. And also the extraction of rare earth elements is one of the most polluting and energy extensive of all the metal extraction processes. So how Passenger wants to mitigate these issues is by developing materials that magnetic materials that do not use rare earth elements, but instead they use materials that are highly abundant in Europe, and not only they are highly abundant, they are also they are easier to extract, associated to lower environmental impact, and also to higher safety for the workers that are extracting them. So this is the ambition of the project, and what the project is currently doing is aiming at the substitution of neodymium-based magnets, so rare earth-based magnets, with two different materials that do not use rare earth elements, namely improved strontium ferrite and manganese aluminum carbon permanent magnets, which are being piloted in two different applications, namely electromobility, so e-bikes and e-scooters, and water pumps. And so the outcome expected is to contribute to a diversification of critical raw materials in the permanent magnet sector, covering actually the whole value chain that goes from the extraction to the material production.
Thank you very much, Stefania. You will have the opportunity to talk a lot about the project. Let's move to the second panelist, Ana Maria Martínez from SINTEF. Ana Maria represents the Reproduce project. She has a PhD in chemistry from the University of Valladolid in Spain. She is a chief scientist at SINTEF, an independent research organization in Norway, where she has worked since 2006 and currently leads the corporate strategic area on minerals and critical raw materials. She has more than 15 years of experience in developing innovative and environmentally friendly processes for the recovery of critical raw materials from waste streams, with wide experience in industrial metal production processes. She is the coordinator of the Horizon Europe Reproduce project, which aims at establishing a closed-loop recycling of neodymium-based magnets from end-of-life products. Thank you very much, Ana Maria, for being here. And please, your opening statement about the relevant aspects that you want to highlight. Thank you.
Thank you very much for the kind introduction and also for the invitation to be here. It's really a pleasure to meet other project colleagues in the subject of raw materials, which is quite an important subject these days. I guess you are all aware of the geopolitical situation and materials, the accessibility of critical and strategic raw materials is really a political issue these days. So we are all here, all these projects here, aiming at establishing a robust European raw materials value chain. I'm the coordinator of Reproduce project, and we are aiming at establishing for the first time an industrial secondary raw materials value chain for neodymium-based permanent magnets. All the way from end-of-life products, electronic and electric waste, until new magnets. So in this way, with readily available wastes that we have in Europe for extracting the very precious rare earth elements, we can establish a complete rare earth permanent magnets value chain. We are tackling innovations that are covering, as I said, the whole value chain. So we start from end-of-life products. We have innovations, automatized pilots that can sort end-of-life products that contain rare earth permanent magnets. We are also establishing and building up robots that can extract the components that have the magnets, the sinter. We focus on sinter permanent magnets. Then we have prototypes that can extract different sinter magnets from the different components. And then hydrometallurgical robust technologies that can tackle all kinds of end-of-life permanent magnets with different compositions in terms of rare earth composition, also on other elements like nickel coatings, zinc coatings, etc. And we are developing automatized, robotized pilots to prepare metals, because we know that for making magnets, we need rare earth metals. And in my opinion, this step is the bottleneck of establishing a good rare earth permanent value chain in Europe.
Thank you very much, Ana Maria. Now the third participant of the third panelist is José Eugenio Ortiz. Thank you very much for being here as well. José Eugenio is a PhD in mining engineering. Is a professor at the Madrid School of Mines and Energy with more than 20 years of experience. Is the Deputy Vice Rector of Research and Doctorate at the same university. And he was Director of the Department of Geological and Mining Engineering. Is author of more than 200 scientific publications and involved in more than 70 research projects. He is also responsible of the clustering activities of DigiEcoQuarry, Horizon 2020 project, and participating in the technical development of the project. Please, José, you have now time, and thank you again for organizing and leading this clustering event, and also the clustering that you created with the synergies of the different projects. Please, now it's time for you to say your opening statements.
Okay, thank you very much. I'm happy to be here and also to be with other sister projects in this cluster. I'm here representing DigiEcoQuarry. It is an Horizon 2020 project led by ANEFA. And we are 25 partners. The main goal of DigiEcoQuarry is to increase the efficiency of the production of aggregates in quarries. We are finishing the project, but we have provided sustainable, or the main goal is has been to provide sustainable supply of minerals for construction and civil engineering. For this purpose, we have optimized the processes in the quarries, in the whole production steps, from the quarry front with the extraction of the aggregates, to the treatment in the treatment plant, also the transport. And with all this digitalization and the development of artificial intelligence services, we have reduced the environmental impact. We have also increased the health, safety, and security of the workers. We have optimized all the processes in the quarries, and we have increased the resource efficiency, the sustainability of the production of the aggregates.
Thank you very much, José, and congratulations again. Now we move to the fourth panelist, César Luaces, representing ANEFA and the project CIMIN. César holds a PhD in mining engineering from the Universidade de Oviedo. He currently serves as Director General of ANEFA, the Spanish Association of Aggregates Manufacturers, FDA and Primigea, as well as Secretary General of Cominrock and the Mining and Life Foundation. César Luaces represents the entire Spanish raw materials extractive sector with a special focus on aggregates. Besides, he is the coordinator of the CIMIN, Rotate and DigiEcoQuarry projects. Congratulations, César, for this great work as well. And please, now it's time for your statement.
Thank you very much. The CIMIN project, Critical Raw Materials, is a Horizon Europe project. We recently started. It's a 4-year project. We start in October. So we are just developing the first phases of the project. We have 21 partners from 10 countries. And this project has been conceived, and this is very interesting to be said, before the approval of the Critical Raw Materials Act, but is just answering to a specific article of the Critical Raw Materials Act, in particular Article 27, which is the obligation to evaluate the amount or the potential of recovery of critical raw materials from existing mining waste facilities. So we developed the project. We applied before these critical raw materials has been approved and published last year. And the idea is to contribute in 2 lines. One is obtaining critical raw materials for improve the supply from European sources. And the second point is on the pillar of circularity. It's all together because we are recovering raw materials, or we should aim to help to recover critical raw materials that were discarded in the past because along the history, these raw materials were not of relevance due to the value chains and the technical needs. Now they are in the center of the political discussion and the strategic autonomy of Europe. And what we want is to contribute with, first of all, a complete methodology that could be transferable to any other raw materials or mining waste facility holder, so they can evaluate with a certain procedure. Even one of our final goals is to be able to establish a European protocol or a standard via SEN, the standardization committee in Europe. But to achieve this, first we need to develop a methodology and to evaluate the potentiality, taking into consideration, of course, the existence of the raw materials, but all the economic, environmental, health and safety, logistical, etc. consideration. I will develop this later on. Thank you.
Thank you very much, César. Last but not the least, we have Carlos Fernando Forero from Azogravas and representing the project Rotate. Carlos is a chemical engineer. For the last 30 years, he has worked as General Director of the Colombian Stone, Sand and Gravel Association, Azo Gravas. He represents the mining industry in the Colombian Mining Policy Advisory Council. He was a member of the board of the directors of the Colombian Mining Authority, and he worked for the Inter-American Development Bank in Colombia during the implementation of corporate social responsibility practices in SMEs. Professor at different universities, teaching and lecturing on industry and sustainability. Is leading the representation of the Colombian aggregate companies in DigiEcoQuarry, and is also a member of the International Advisory Board of the Rotate. Thank you for being here as well, Carlos. Please, your opening statement now.
Thank you very much, Susana. It's a real pleasure being here in Belgium, in Brussels. As you just read, I'm from Colombia, and with 30 years experience in the mining industry, I would say that these projects are real world-class projects. I'm glad we have this morning to share every project. Rotate stands for Circular, Ecological, and Essential Critical Raw Materials. The main pillar of the project is to reduce the environmental footprint in the mining industry. So to do that, we first of all, we have to measure. Once we measure, we assess, then we manage, and finally we implement solutions. We have divided the project in 3 areas: monitoring and assessment, the second one, processing solutions, and the last one, efficiency solutions. I will elaborate a little bit more during the panel. For the monitoring and assessment, I just briefly will mention some aspects of these 3 areas. For monitoring and assessment, the first thing we deal was with mining closure and remediation guidelines. There's a saying in the mining industry: to open a new mine, you have to know how to close it. So we begin with those guidelines. Then we have an environmental management platform, also environmental emissions estimation, air, water, and solid waste. Of course, energy is very important, energy efficiency, and a module of risk assessment, environmental risk assessment of the project. That's for monitoring and assessment. In terms of processing solutions, there's a very interesting pilot project of mine. It's a celestite mine, Celestine. So those spiritual things, but the metal is used also for that. But the celestite is very important in terms of the strontium that they produce. Strontium is very useful not only for metal alloys, but also for cancer treatment. In that site, that specific site, they historically didn't recover 100%, which is very complicated in mining, but at least 80% of celestite. So the idea is to have a secondary recovery, a more technological and technical approach for the recovery of celestite. Also, we recover in the sand and gravel industry. There are some sites that they have gold. So we are in the process of developing technologies to recover gold from sand and gravel operations. That's processing solutions. And third area is efficiency solutions. For example, with mobile crushing companies, producer companies, suppliers, we are developing technologies to have mobile crushers with less noise and dust. And finally, using artificial intelligence and digitalization, we share this with DigiEcoQuarry. We have the characterization of the granulometry of some minerals, especially sand and gravel, based on artificial intelligence.
Thank you very, very much. So we have now already an overview about the 5 projects that are involved or participating in this nice cluster. 2 projects from Horizon 2020 and 3 projects from Horizon Europe, with more than 100 entities participating in this group of projects, which is fantastic, from different countries. And this is really the beauty of the European Union, is the possibility of putting together these entities and the knowledge of all people that are participating in these 5 projects. Now we are exactly on time to start the next part of our program, which is the panel discussion. And in this part, I'm going to address one question to each panelist. So the first question, I do the round, and then I will go for the second question to each of you as well. So each of you at the end will have 2 questions, but the first one will be for the first round and the second for the second round. And if I may, I will start with Stefania again from the project Passenger. And my first question to you, Stefania, is the following. The Passenger goal is to develop an innovative way to produce permanent magnets without rare earth materials. Can you provide examples of specific technologies or methodologies you are exploring to increase the efficiency of using other elements in combination with environmental performance that could be applied to other processes? So,
Yes.
is this clear, the question?
Yes, perfectly. Thank you very much. So, what Passenger is doing, like one of the main of the core action, is the development of novel magnetic materials, but not novel in the sense of never seen. Basically, what we are doing is taking already existing magnetic materials and improving their properties to make them suitable for application in those strategic technologies that I mentioned earlier. So the main the main action is basically material engineering. Through a number of processes that are proprietary of some of our partners and that go from the lab scale to the industrial scale, we are able to modify magnetic materials to change their structure, and also by adding specific additives and applying specific temperature treatment, we are able to obtain improved materials that have better performances that the same material, let's say the classical material. Having in mind the specific example of our improved strontium ferrite. So compared to classic strontium ferrite, it has better performances, higher coercivity and higher remanence, and also has better performances with respect to sensitivity to temperature, for example, which is a known problem, especially in the cold. Is a known problem of strontium ferrite. And our processes, the processes used to produce passenger magnets, more cost-effective, more environmentally friendly? Yes, they are. It has been shown both from life cycle analysis and health, safety, and environmental assessment that passenger processes are more environmentally friendly. They are also associated to lower risk for the workers that are producing them.
Thank you very much, Stefania. Very, very interesting the way that you are conducting the work. And now we move to Ana Maria from Reproduce. And my first question to you is the following. The main goal of Reproduce is to set up the first sustainable and complete European rare earth elements recycling value chain at industrial scale. able to produce the rare earths from end-of-life products. Can you explain how this specifically translates into lower environmental impacts together with competitive costs? So a very important connection between the environmental performance and the costs. Please.
Yes, thank you for the question. Of course, as previously stated by my colleague Stefania in her introduction, rare earth permanent magnet value chain is completely controlled by non-European countries. And I mean completely controlled from the very beginning. So primary production, processing, metal production, and to some extent, quite a large extent, also permanent magnet production. We know that all these processes through the whole value chain to obtain the permanent magnet that are needed for the green energy transition, all these processes mean quite a large environmental impact in every of the steps. So this is one point. So what we are aiming here in reproduce based on secondary raw materials. Of course, we hope that in Europe will be primary production of rare earths. I really hope also, but for the moment it's not so. So we rely on ways that are readily available in Europe. So we are developing innovative technologies that are environmentally friendly. So we have environment always in our minds, of course. There is no sense to propose an innovative solution that can be implemented at commercial scale if it doesn't have an environmental good footprint. This is a fact. More and more end users are asking for the environmental footprint of the products they are using, right? So this is one point. We are taking care at each step a good environmental performance of the different technologies. But perhaps one of the innovations in reproduce, which is developed after another Horizon 2020 previous project that I also coordinated, called RE4 Europe, is based on the electrolysis technology. As I said before, one of the bottlenecks to establish a complete, robust permanent magnet value chain in Europe relies on metal production. This is something some called metallization step. So we have to produce a metal in order to make the magnets. So reproduce based on RE4 Europe technology is based on using a mixture of rare earth oxides extracted. So we skip the rare earth oxide separation step, which is highly environmental detrimental and also energy intensive steps. So we are quite sure that also as in the RE4 Europe project, the life cycle assessment will give very good environmental footprints. We are 1 year to finalize the project and getting data from the different pilots that are built up. So we will come to that numbers. And when it comes to cost, of course, we are going to compare to market prices. We are going to compare how much does it cost a rare earth magnetic alloy to make a magnet with a certain composition. We just choose one composition and we see how much is the price in the market. We cannot foresee, but the only thing that I can see is that I can say is that in the previous project, it was quite a competitive cost because, as I said, we are going to skip some of the steps that per today are used because we have a new electrolysis technology that allows to use a mixture of rare earth oxides. So we skip the separation. So we are confident also that it will be positive from the cost perspective. We will see.
Okay, I'm sure that you will achieve the results that you expect, but of course you still have some time to work on that. Thank you very much. And now I'm addressing the next question to Carlos Forero, okay, the representative of Rotate. And my first question to Carlos is the following. One of the pillars of Rotate is reducing the environmental footprint of mining process. By what means will you achieve it? So again, as the other colleagues mentioned already, the environmental aspect that is very well addressed in the previous projects, we have now here a big challenge of the Rotate project that is reducing the environmental footprint on the mining process itself. So please, Carlos, the floor is yours.
Thanks, Susana. Yes, it's true. It's the main pillar of the project, reducing the environmental footprint in the sector. So as I mentioned before, we have three areas: monitoring and assessment, processing solutions, and efficiency solutions. Let me talk a little bit about the monitoring and the assessment. One of the areas of the project is to elaborate an environmental management platform. Of course, that is not a new platform, because there are many platforms in the industry. But the idea is to have the most comprehensive platform to even talk to other platforms and to get information into the systems and get the right solutions. So the platform is composed basically by data collection and monitoring, which is the first thing in any platform. Then we have to realize if you are in the compliance framework, to understand that the regulations are followed by the operation. Then you have the reporting, which is very important in terms of ESG today. Then risk assessment and the incident management for the environmental aspects. And finally, planning, the sustainability planning. So the platform is very important in terms of monitoring and assessment. In processing solutions, I mentioned celestite, I mentioned aggregates, but also we've been working on developing technology to improve the flocculation, to not just to separate what is a residue from the main product, but also to reuse the residue. So we have what we call the sludge super thickener, which is a real new development. And finally, on efficiency solutions, apart from the new mobile crushing project with less noise and less dust, we have also new energy-based rock crushability. So crushing is a crucial area in the mining sectors. We develop a new energy-based rock crushability. So those are based on the main pillar, which is reducing the environmental impact, the areas we've been working on Rotate.
Thank you very much, Carlos. So we have already here a very strong synergy on these three projects that we also addressed in this first question about the environmental impact and about the environmental concerns. So I think that this is a very important message, that the environment is not left aside in this sector, at least from the point of view of these projects where you are working. And we are now going to Cesar to keeping the same subject, but in a specific question for the Eximin CRM project. So the project, the acronym is Eximin CRM and stands for Sustainable and Circular Production of Mineral Critical Raw Materials. And the question is, how is this project addressing the challenge of recovering these critical raw materials, considering not only the availability, but also other relevant issues like the environment, the safety, the economic, and the logistics. So we are a little bit further than the environment, but also addressing the safety, economic, and the logistics in this project. Can you please give your view about how the project is addressing this challenge?
Yes, Thank you. As I mentioned in my first statement, it's central for the project to be able to deliver available critical raw materials across Europe linked with the mining waste facilities. I have to say that there's 1,000 of mining waste facility that were created in the past, in the beginning of the times, because we don't have to forget that the extractive industry is here since the Stone Age at least. So now there's a lot of abandoned old mining waste facility, but not only that, we also have the already existing mining waste facility linked to an active extractive site, an active mine. So so for us, first of all, one of the achievements of the project is to be able to obtain the critical raw materials, but also to solve the environmental issue of I don't know, a certain mining waste facility abandoned 100 years ago in the middle of nowhere that is there. We don't know what to do with this material. So we need to deliver some tools in order to solve this issue. We have in the project 4 pilots. 3 pilots are in relation with active sites, but 1 pilot is tackling a full region, a mining region in Spain, that is Asturias, where there's an inventory of mining waste facilities, and they identify 100 to 1,200 mining waste facilities by the Spanish Geological Survey, which is one of the partners of the project. So they made a first assessment of them, and after a preliminary screening, we are focusing on about 20 of these mining waste facility in order to obtain some critical raw materials, like, for instance, fluorspar or barite. I have to say that in the project, we have a full list of critical raw materials that are in the 4 pilots, but I don't think it's interesting to read the list. What is interesting is to understand the flow of work of the project. So imagine we need to solve the issue. I have a mining waste facility. How to get something out of there? So the first point is to identify where, what kind of mining is behind in the past or in the present of this mining waste facility, in order to understand what kind of minerals could be found in this mining waste facility. So that's the first, let's say, step. Then once we made this identification, we need to put into the discussion other things. It's not only a question of having the critical raw material, is it feasible? Is there an economic model behind? Because of course, maybe there's materials, but the obtention of them is completely uneconomic, impossible to manage. So also one of the things we are doing is to try to find a smart way on linking the mining waste facility with potential end users. So we are, let's say, making the link between abandoned mine facility with the value chains behind, because we need a client for the material. If this is possible, a local client, a consumer of these raw materials in a local basis, just to skip the impacts, economical, logistic, and also environmental impact of the transport, which are very high. I imagine this mining waste facility could be in the middle of nowhere, so you don't have even a road to access to these mining waste facilities. So you may find a big amount of materials, but with a lot of logistical issues. Also, because we are tackling with all mining waste facility, maybe not rehabilitated, because this legislation is relatively new compared to what could happen in the 19th century, for instance. So maybe there's a natural recovery of the mining waste facilities. So we also need to address the environmental situation of the mining waste facility in order to see, because maybe there's a priority species there, so you cannot touch anymore. So there's many other things, like, of course, health and safety. We need to have everything we will do should be addressed on biohealth and safety perspective in order to guarantee the safety of the workers. That is clear. So there's a lot of different issues. When you think about the raw material, you maybe lose the focus of behind each one, there should be an economic model in order to guarantee if this is feasible or not, because at the end, what the Commission wants is that the individual companies or the public administration holding these mining waste facilities are able to obtain something. So we need to deliver something that is transferable, etc., etc. I will explain later on how we are achieving this. Okay?
Thank you very much, and very, very interesting. So is as Cesar said in the beginning, is a very new project that started not a long time ago. So and very, very challenging. So addressing all these aspects is very challenging, but at the same time, it's good that you have contact with the other projects, and you are in a very good position with the entities where you belong to gain also some or receive some knowledge from the other projects and to develop a little bit further the knowledge, the global knowledge that exists in the sector and in the field. So it is great. Thank you very much. And now the first question for José Eugenio Ortiz, the coordinator, the representative of DigiEcoQuarry. And my first question is the following. So DigiEcoQuarry has implemented digitalized, automatic, and real-time process control for aggregate queries. Can you explain how this translates into lower environmental impacts and increased social acceptance? So an aspect that is extremely important. So we talked already a lot, or you talked about the environmental aspects, the environmental impacts that were not left behind in your projects, and all projects are focused on these. But now we need a little bit more related to the social acceptance, not only the proved reduced environmental impact of the solutions that you are developing, but now how are we going to address these in terms of the social acceptance and all these difficulties that we sometimes find from the part of the society and the citizens and the public in general. Please, José.
Yes, thank you. Yes, as you mentioned, reducing the environmental impact is very important, but the social acceptance is a key point for mining in general. And as I mentioned in the introduction, we have increased the efficiency of all processes in quarries. Well, these new methodologies can be extrapolated to other mining types of mining, but I'm going to put different examples about this reduce of environmental impact and in the increase of social acceptance. For example, for the site preparation or the extraction of the material, we have increased the or reduced in the blasting, we have reduced the use of explosives and using artificial intelligence. And this means that we have also reduced the production of fine material and the reduction of dust. So for the populations that are around the quarries, around the mines, this is a very important issue. So reducing this fine material is very important. We have also increased the efficiency of the transport within the quarries with sensors optimizing the routes of the mobile machinery. And this also produces a reduce of the dust and the decrease of the fuel consumption. So In both cases, we have reduced the environmental impact and we have decreased the production of dust. We have also one quarry within a town, within a city in France, which produce recycled aggregates. It is very important for, well, not for this quarry, but for all of them, but especially for this one in Toulouse, to reduce the noise of the crusher and also the dust production. So we have increased the efficiency of the crushing step. And this has been important for this town, for this village. And also regarding the processes in the processing plant or in the treatment plant, the detection of mechanical failures. We have developed an artificial intelligence service regarding this. So we have, in this case, reduced the impact of stopping suddenly the production of in the treatment plant, but also we have developed an artificial intelligence service in which we can forecast, or we have tried to forecast the consumption or to reduce the consumption and increase the production. So that means the decrease of electricity consumption, the decrease of fuel consumption, and also with this service, because in this one we have taken in consideration internal inputs of the quarry plant, but also the meteorology. So with the forecast of how the environmental and internal conditions would be along a certain period of time, we have been able to optimize the production and reduce the electricity, fuel consumption. We have reduced the dust production. And that means, as I mentioned at the beginning, less environmental impact and more social acceptance of the mining activities. Mm-hmm.
Thank you very, very much. So we finished the first round of questions. And as everybody can see, we addressed already the part of the environment, availability of materials, social acceptance, digitalization and artificial intelligence, logistics and transport, safety, economic models. So in fact, these 5 projects are doing a fantastic work, addressing several aspects that are crucial for the development of the economy, the European economy. Now, Stefania, I go now for the second question to you. We are keeping the time. And the question for the passenger project is the following. With the advancement of optimization in recycling of materials, what role do you see for emerging technologies in reshaping the future of mining processes? So let's go to these new technologies for the future development and sustainable development of the mining processes. Please.
Yes. So for sure, there is a big role ahead for emerging technologies in reshaping mining, as well as many other technological sectors. Specifically regarding mining, I think we can reasonably expect that thanks to emerging technologies, AI, overall, will make mining greener, more sustainable, more automatized probably, as well as more data driven, most likely. Then we we might reasonably also see a decrease in mining, but more in the sense of an optimization of the process. Then will there ever be a future where we won't need to mine anymore to source for new materials? Most likely, no. I mean, even if recycling technologies become really good, and we are able to recycle materials at 100%, we will still need to face the increase of demand for specific material that most likely will come from the same emerging technologies that contribute to shaping. Let's take again the example of AI. To run AI, we need infrastructure, we need computing, we need servers, and all of these require materials. So I think that there is a sort of circularity also there. So those technologies that will shape mining, at the same time also mining will shape them as well. So it's an interesting future, and I really look forward to see how it will develop.
Thank you very much, Stefania. Very interesting. And now we move to reproduce. Sorry. To the second question to Ana Maria Martinez. And the question is the following: how is reproduce addressing the challenge of ensuring clean energy and mobility solutions with the generation of exponential growth in demand for raw materials such as the rare earths?
Yes.
So, very important as well.
Yes. Well, rare earths are classified since the first list of the European Commission in 2011 as one of the most critical materials. And this is because they are used in many important energy technologies for the future of Europe. So the demand, I mean, no matter if it is a high demand scenario, low demand scenario, middle demand scenario, the demand is high. And it's high already by 2030, and of course, even higher by 2050. So we need the rare earth elements that are needed for permanent magnets, that are needed for the clean energy solutions and electromobility. Those rare earth elements are neodymium, as you probably know, praseodymium, dysprosium, terbium, and we don't have them. We are dependent on exports of third countries. So what we are aiming in reproduce is to establish a sustainable and also robust value chain that can provide these materials. We have 15 partners in reproduce, covering the whole secondary value chain. It is an innovation action, so we are at quite a high tier level. And all the different industry partners, of course, it's an industry-driven consortium, all the different industries in the different parts of the value chain have the capability and have the wish to take these innovations on the market. We have the know-how in Europe. We don't need take-off agreements with anybody outside Europe. We can make these materials in Europe. And this is what we are aiming for, and hopefully presenting good business cases for companies, because in the end, of course, we have to have a positive business cases. Hopefully we can enforce this important industry in Europe if we want to ensure a robust rare earth permanent magnet value chain.
Thank you very much, Ana Maria. Very interesting indeed. And you are absolutely right when you mentioned that the business cases are important, and of course, the maintenance of the companies depends on that, and the survival of the companies depend on that. So it's very important also to pay attention to that aspect of the costs, the competitive costs that you mentioned in the previous in your previous question, and now in this one, how you are ensuring these clean energy and mobility solutions. Thank you very much for that. And now we go again to rotate to the second question to Carlos Fernando Forero. And the second question is the following. ROTATE stands for Circular, Ecological, Essential and Critical Raw Materials. What specific strategies or innovations in the project implementing to enhance circularity across the mining and quarrying value chains are you working on?
Okay, thank you again, Susana. This is the fourth area, which is the valorization solutions. We have a full package of activities and projects to add value to resources, to recover resources, mining resources. For example, using advanced mining water treatment, we have developed an eco-efficiency flocculant. I mentioned how important is flocculation, this chemical process. So we developed an eco-friendly flocculant. Also, the valorization of aggregate residues used for the construction industry also, as a concrete filler, for example. Those are fines. A result of the process of aggregate reduction, supplementary cementitious materials also, and lightweight aggregates. The valorization of the aggregate, the sand and gravel industry. Also, from those residues, we use sludge for 3D printing, which is a very common technology right now, especially from natural stone sludges. We have a technology, we've been developing a technology for valorization of mine tailings. Mine tailings is a real headache in the industry. So we've been trying to introduce two techniques, geophysics and teledetection. Those are non-invasive techniques where you could detect moisture, thickness, contaminants, the composition of certain types of materials that you want to see. Very, very efficient, non-invasive, as I mentioned, and very friendly in terms of the environmental aspects. And finally, we also have an standardization, regulation, and certification for construction, which is also within the value chain, one of the most important areas that we focus. The valorization solution is the area. The idea, it's in terms of the circular economy, not only to have no new pits, because natural mining or mining of natural resources will be there forever. But if we could improve being more efficient and more productive, of course, we could reduce a little bit the opening of new pits.
Thank you very much. Very, very, very interesting. So I hope that you achieve all the objectives because they are very, very challenging, but at the same time necessary for the development of the sector. Thank you very much. Now I have the second question to Cesar, representing the project SCMIN CRM. And it is also very interesting, this question, that is, can you provide insights into exciting advancements for enhancing circularity that could be applied to other mining regions? So you mentioned that you have pilots in this project. It is still in the beginning. So it will be, you will achieve concrete results in those pilots. And now we would like to know a little bit how the advancements that you that you expect to achieve in terms of circularity could be applied to other mining. This is very, very interesting.
In fact, in this project, we have several final products, but we conceived the project focusing on the transferability of the results, because it's not a question to solve the issue in for pilot, is to deliver something that could be used or applied, let's say a kind of methodology, a smart methodology, I will come to this in a second, to be used by anyone. Because so the model, this model, and the standardization of this model, because we have a one standardization body into the partnership, is important. For this transferability, we also are building on 2 previous projects that are here. From DigiEcoQuarry, we would use the platform that we are developing to use some of the tools, but also to add some other tools to this platform. So that will make this methodology available everywhere for everyone, because it will be available in the internet. And from Rotate, we will take some methodologies for the environmental footprint reduction strategies, and also for enhancing the circularity. So this is, let's say, as transferability tools. But how will this works? Because of course, when you have, imagine a certain mining waste facility there, you don't know exactly who is the owner, what is in there, how much this will cost, etc., etc. Let's say we need to tackle this issue with a certain logic. I mean, first of all, we need to have a very cheap screening of this mining waste facility. What I mean cheap is that we cannot start to see if there is some critical raw materials by making investigation on the field, because that will cost money, and then the users will never apply this. You need to have certain logic. This mining waste facility is coming, from instance, from an aggregate quarry, so most likely there will be nothing relevant in there in terms of critical raw materials. But if this is coming from a former mining that is with the geology of the deposit linked to some critical raw materials, then it will be of higher. So we need to deliver step by step a methodology in order, and of course, the more you go through this decision tree, the more you will need to invest, but you will be investing with the logic that you are investing in the right places instead of everywhere. So that's one point. Another important point is the quality of the materials. And that is why in this project it's very important to have the link with the final user, because the final user is going to ask for the technical specifications of the critical raw materials they need for their process, in order to try to obtain what they need in order to make the link between this deposit and the user. So these kind of things are those we are integrating in the project. For the analysis of for instance, for the analysis of the content of the mining waste facility, we will use artificial intelligence models in order to try to minimize the investment for evaluate the deposit in terms of the content of this raw material. And one very important thing is that there are some raw materials that are not critical but are involved in the process. Just as an example, we may have a mining waste facility with critical raw materials, but the rock that is not mineral critical raw material could be maybe used as aggregate, and you need to put this into the economic equation and the calculation and the economic model of the mining waste facility. So you will be able to recover and to produce natural aggregate from old rocks from the deposit and they will be able to contribute to manage on an economic way these many waste facilities. So there are many, many, many things that has to be put together. And then for us, the main goal is to deliver something that could be useful to fulfill the obligations of Article 27 by any owner of a many waste facility in Europe.
Thank you very much, Cesar. It is very important that you mentioned that work is done step by step. So taking into account also the interest of going further to the following step, because sometimes this is not very clear to all citizens and to the society, and they start sometimes creating some barriers even before the first step is done and before assessing if it is really important to go to the following step or not. So it is very relevant that we openly transmit this message that the work is done step by step and according to the interest of going further in the development of the mine. Please.
And if I may, the obligation of Article 27 is here, but there's no methodology behind. So one of the outcomes of the project, and we will try to be able to deliver this as soon as possible because the obligation is here since last year, but there's no methodology behind. And I say that because, for instance, in Spain, there's an ongoing discussion with the public authorities. Okay, we as companies, we need to investigate that, but how? So what we would try to deliver, and this is one of the things we will try to have with the policymakers interaction, is maybe to deliver a kind of methodology that could be used by across Europe and supported by the Commission, because at the end, this project belongs to the Commission because it's funding it. So that's one point. And the last point that I want to mention is the permitting. The permitting, because if the mining waste facility is linked to an existing live permit, it's okay. But if this is a mining waste facility in the middle of nowhere, we have an issue of to discover who is the owner of the land, how to get the permit to do something there, and if we get at the end of the investigation of the procedure, the conclusion is this is feasible. We can process the mining waste facility to recover the critical raw materials. We need to get a permit. And currently, in many countries, this last permit is a barrier. So we need to, let's say, maybe to come back to the authorities at European level to say, okay, you have a very good intention with this Article 27, but maybe there's a barrier we should try to skip. I don't know, legally speaking, how. This is too early to discover, but this is an issue we need to solve. Yes. It for sure. If not, it will be almost impossible to tackle the majority of mining waste facility in Europe.
Yes. This is why it is very important that together with the other projects you are discussing the issues that you are encountering, because then your voice will be stronger and you have the possibility to discuss among you the most important aspects that you should transmit then to us. And then we, even in HaDEA, we have a policy group that is in very close connection with the parent DG to discuss these aspects. Is the policy feedback that we call it, exactly to give some feelings that we got from the stakeholders of the projects, not only light feelings, but strong convictions that we should go in this way, and the stakeholders, as stakeholders, we need this and that, because the policies are done for you, for the stakeholders. So it's very important that you are involved and then you participate when you are asked to be consulted and to give your opinion in open consultations, for example, you can participate on that. Thank you very much. Very, very interesting. So we still have 3 minutes for the last question to José Eugênio Ortiz for DigiEcoQuarry. And the question is related to the previous one. And it is the following. Given the rapid evolution of technology, how is DigiEcoQuarry addressing the challenge of ensuring that digitalization processes developed within the project remain relevant and adaptable to future mining practices? So not only that you are developing something that you are using in your project, but that the solution that you are constructing, let's say like this, remain relevant and adaptable for future mining practices. So please.
Okay, thank you. Yes, well, the answer to this question, I think that has commented something, because in the DigiEcoQuarry project, we have developed a platform that is being used in STEAMIN. So as I mentioned in my second intervention, the services that we have developed in the DigiEcoQuarry can be extrapolated to other, not only to aggregate quarries, but to other mining type of mining activities. But well, regarding quarries, I think we are at the beginning. We have done a lot, but much can be done in the future. Because one issue that we had at the beginning is the availability of data on the quarries. And we selected 5 types of quarries representing the thousands of quarries that are in Europe and in the world. So I think that the next step would be to develop these services in all the quarries. That's the first point. But another thing is machine learning. So yes, we haven't with, for example, with artificial intelligence services. Yes, we have developed some of them, but these services need to learn about the about the data that is producing the quarries, the mining, the mines in general, and that would increase the optimization of the processes, and in the future, well, I think it's a field that it's beginning now and can be developed much more. Mm-hmm.
Yeah. So it is the beginning of a very nice story.
Yes.
About the use of the artificial intelligence, machine learning.
Mm-hmm.
So, well, it's very, very interesting, and and it's beautiful to see the beginning of something that with so many expectations that we have, and the things that we imagine that can happen in the future in this sector and in other sectors as well. So thank you very much. We finished exactly on time. Exactly, not 1 minute before or after. No, exactly. And now we have time for questions from the audience. I don't know if it is Lorena. Oh, so just these messages to the audience. In case that you have any question, please, you can type on the chat, is that? And someone will read here, and you please identify yourself, the person, the company, the country, or whatever you want, and indicate to whom the question is addressed. Please, I was looking at my computer, but I forgot that we have the camera. We are so used to use the computers now. So please, to the audience, is there any question? You just need to type the question, to identify yourself, to indicate to whom you are addressing the question, and The beginning is always difficult, but please,
Ice breaking.
yeah, so you don't need to talk, it's only to write.
Which helps.
Yes, we still there. No questions by now? Okay, so we have a question. Then just to let you know that in terms of the agenda, after the questions from the audience, we still have some questions, cross-cutting questions to all projects here present. So this is not only to use the time, it's only to give the possibility of the audience to participate and to have any aspect that concerns you clarified by the representatives of these 5 very good projects. Please, Lorena.
Question from Íñigo de Amezcua, who is communications manager, and it's an open question to all projects. He asked, how do you think these projects could have to improve the social perception of mining in Europe?
Okay, very good question. So we have only a few minutes for this part because, as I said, we will have then the cross-cutting questions. But please, who wants to start about this very important aspect that was already touched here, right? The social acceptance. Who wants to start saying some things?
So being not from Europe, I will provide you with some ideas of what we've been working on DigiEcoQuarry and Rotate, where the social issues are very important. 3 strategies that we developed for the triangle: community, authorities, policymakers, and workers. So community engagement strategy, I'm not going to elaborate in details, but community engagement strategy is included. Social awareness and understanding among workers of the benefits of the new technologies, of the use of circular ecological strategies, etc., etc. And most important is the relation and involvement of policymakers, as Cesar was mentioned. It's a real necessity, not only in Europe, but in the world, that authorities, mining and environmental authorities, understand the industry, get clear and quality information from companies, and speed environmental permits.
Thank you very much, Carlos. Is there something else that the other colleagues want to say about this? Ana Maria?
Well, Reproduce is not about mining, but we have also other projects about mining. And in my opinion, involvement of the local communities are essential. I mean, they have to get to know the possibilities, first of all, and to be informed on the different activities that the mining companies are going to do, to involve them at early stages. I guess it's not nice to get to know that, okay, a mine is opening next year. Okay, they have to get involved. They have to know that maybe there is something in their land that is wanted in Europe and is important for the future development of Europe. And also, of course, on the different industrial activities that are going to be performed there. They want to get to know probably on the environmental impact in their area, etc. So involvement of local communities, I think, is essential.
And participation from the very beginning, and above all, to give openly the information. And so for them not to get influenced by other people that are not sometimes with good intentions, and they can have the direct information and transparent information and clear information from the owners or the developers of the project. I think that we all agree on that. That is very, very important. I don't know if someone else wants to add something, please.
Yes, I think that also it is very important the dissemination of what we are doing to general public because well, everybody wants a house, everybody wants a car, everybody wants a mobile phone, but nobody wants a mine in the surroundings. But I think it's very important to present the people in general that mining activities and recycling is very important for all of us, for the social development, and I think that is another key point for us, for all the projects that are involved in this kind of activities.
Please, Cesar.
Yes, if I may, in all the project, we have seen that environment is in the core, in the central part of the project. That means that all the project, if we are successful and we are on the way of being successful, we will deliver tools to improve things in terms of environmental management, less impact because we are increasing recycling, etc., etc. So we are contributing to a more sustainable, more environmental friendly, a more, let's say, transparent raw materials industry, not only extractive industry, but raw materials industry. And that will contribute certainly to improve the perception of the public, general public towards our industry. In addition to that, in some of the projects, we are supporting and we are developing tools for relation with the social community, integration of women in the industry, which is, for instance, in the extractive industry, we are around 11-12%. So there's a lot of things to be done there. We are improving reporting with reporting tools. So we are becoming or contributing to be more transparent towards the society. So I think that little by little we are improving. We are doing things better and better, and that will come.
Yes, yes, for sure. For sure that you are already doing everything very well. That's why the projects exist, because, as you know, the competition now to get one proposal funded is very high. So now we have to choose from very good projects or sometimes excellent projects, the best one to be funded, and this is extremely difficult. And I know, because it's a part of my work as well, to supervise one topic per year, and I know also from my colleagues doing the same job. So the competitiveness is very high, and the good, excellent, I would say, excellent projects are funded. So we are completely comfortable in relation to that. And what I always say to the projects that I'm monitoring, and to some of you, I already said this because I was or I am the project advisor, is that communication is very, very important. And so use the social media, because it is now platforms that everybody sees. You should communicate not only to other researchers, not only to other stakeholders, not only among the projects to industries, but as well to the normal citizen in the street that have access to the social media. They should know what we are doing with the funds that the European Union is using to fund these projects, because the money comes from that. So the money doesn't fall from the heavens. So public money. It is the taxpayers' money. So it is important that we show to everybody what we are doing with the money, the results that we are achieving. So that's why I think that social media, and I always insist on this, show the results not only to researchers, not only to industries, to everybody, to the normal citizen, because they need to be informed. Because if in one day they will face a challenge of having a mine or something, an industrial plant close to them, they need to know already what is going on. They can already be informed about the subject. So if we don't have any other question, I'm going to pass to the final part of this event. So we have 20 minutes, around 20 minutes to discuss cross-cutting subjects. And I have 4 questions. I'm going to put one by one, and each of you, you can reply, you can say something about this question in case that you have something to say, of course. But we have to limit to around 1 minute for each answer, unless someone doesn't want to talk, and so you have another minute. And the first question is the following. Could you explain how your project align with the objectives of the Critical Raw Materials Act? So, as you know, the Critical Raw Materials Act have been discussed already in several platforms, in several events, and Cesar said that one of the projects were submitted even before and was approved for funding even before the adoption of the Critical Raw Materials Act. So now the question is, how is your project aligned with the objectives of the Critical Raw Materials Act? And I just want to remind you that we have here in this panel Horizon 2020, as I mentioned already, and Horizon Europe projects. So in different stages of development. 2 of them will finish this year, 2025. Another 2 will finish in 2026, and 1 will finish in 2028. So we have, you are in good position to reply to any of these questions. Please, who wants to start? How your project aligns with the objectives of the Act? Please, Carlos.
Okay. Case of rotate, we'll mention 4. We introduce new technology for efficient recovery from already existing mining operations. We also have very clear that we have to support the target for recycling in the European Union by 2030. And I would say that one of the most important geopolitical aspects of the critical raw materials right now is to reduce the dependence from imports, foster industrial symbiosis between mining and construction, for example. We also have enhanced sustainability, and we really think that the real focus of the project should be on the objectives of the Critical Raw Materials Act.
Very good. Very good, Carlos. Thank you very much. Anyone else wants to explain how the project aligns with the objectives of the Critical Raw Materials Act?
Yes, if I may. Passenger was funded many years before the Critical Raw Materials Act, but it's still very relevant and very well aligned to it, because by providing solutions, alternative solutions to critical raw materials, specifically in the field of permanent magnets, it's supporting the implementation of a more sustainable value chain for permanent magnets, so supporting also a resilient and sustainable supply of materials for permanent magnets, because as said, we're using materials that are widely available in Europe, and so also promoting the self-reliance on Europe in a field that, as mentioned before also by other colleagues, it's really relevant and strategic for the future of Europe.
Very well, Stefania, very good. Is there anyone else who wants to mention something about this? Please, Ana Maria.
Well, in general, with the Critical Raw Materials Act, we want to establish robust raw materials value chains in Europe, right? This is the aim. But it has established several benchmarks that are going to be fulfilled by 2030, which is tomorrow, so to speak. And these benchmarks are dealing with primary extraction, processing, because processing industry in raw materials is almost inexistent in Europe, diversification of imports of raw materials, and recycling. 25% of materials that are going to be used must come from recycling. And the critical raw materials are, the recyclability is in many cases less than 1%. This is the case of rare earths. Why is that? So one can imagine, and I think the main reason is that, okay, maybe there are some technologies that are at commercial scale for extracting the rare earths in the form of oxides. But who is providing the magnets to be recycled? Who is going to make the metal afterwards that leads to the magnet? So we don't have resilience value chains in many of the critical strategic raw materials per today. So reproduce in that case will help at least to present opportunities for the rare earth permanent magnet value chain.
Very, very important, very relevant, as you said before, for the new technologies, of course. Anybody else, or we pass to the following one?
In the case of CIMIN, as I mentioned, is linked to Article 27 and with the two goals of supply of raw materials from Europe and also to enhance circular economy. But going into the detail of Article 27, what we will deliver for this is a tool for the preliminary economic assessment study that is compulsory for all the economic operators, a methodology also for identifying the materials, because all the member states are obliged by November 27 to adapt and to have a tool, a website to make available the information related with this mining waste facility. So we will deliver several elements that will fulfill the different obligations that are in Article 27.
Very well, thank you very much.
Yes, and well, aggregates are not considered critical raw materials, but well, they can be, well, the rocks, the host rocks that contain that the critical raw materials can be used for aggregates. So, and also the methodology developed in DigiEcoQuarry can also be applied in for the production or recycling, even the recycling of critical raw materials.
Thank you very much. So I think that we are that you are ready now for the second question that is also very interesting, and it was already lightly addressed by some of you, and it is the following: how do you envision the impact of artificial intelligence and other emerging technologies on the optimization of processes related to the raw materials value chain? So how do you envision these new technologies to be useful in these processes that are related to the value chain of the raw materials? Jose, do you want to start? You mentioned already something.
Well, I've talked about this before, about the use of artificial intelligence. I think it's the present and the future. But about other emerging technologies, I would say also robotics to be applied in mining operations. That would be an important development. Yeah.
Thank you. Something else?
In our case, for sure this will have it's already having, but it will have a greater impact. And just to complete, because that will also have an impact on the workforce. We need to reskill the workforce. I believe that artificial intelligence will not be against the workforce, but the opposite. It will be a good tool to work better, safer, in a safer environment, etc. So it's a potential positive tool for everyone in a site. So it's not a threat for the workers. It will be a challenge for all of us to reskill our people, but also this will change a little bit the profile of the professionals that will be in the industry working for us. But because right now we have machine operators, and maybe in the future we will have professionals guiding the machines from a laptop from an office. So that will be we think that the industry in 2050 will be very, very different to how to the shape we have today, and for a better and more efficient and more environmental friendly industry. That's my view. But there will be a number of challenges behind.
Yes. We will go in the third question to the picture in the 2050. Now, anything else anybody else wants to comment on this impact of the artificial intelligence?
Right. Yeah, we have also in Rotate the use of a field or of artificial intelligence, which is the computer vision. Computer vision allows us to see, interpret, comprehend images and videos of the real world, similar to humans. So we use that technology for real-time granulometry control in a Rotate project.
Very good, very good. So we have the artificial intelligence, robotics, computer vision, and the positive view that this will not combat or will not exclude the participation of the workers. On the other side, it will be beneficial because it will improve the conditions of the workers and the safety. And well, it's really great. Please, Ana Maria, you want to?
Yes, just one thing, because of course, for recycling, I think artificial intelligence is very important, because we have many different end-of-life products that we discard, with many different designs, with many different shapes. So we can't afford to have an economically sustainable recycling value chain if we don't use artificial intelligence, which will help robotics, which will help to automation of the different steps. So for example, in Reproduce, we developed intelligent sorting machines that are based on visual recognition, enhanced with machine learning. So then we can't have a manual operation for sorting or for dismantling in Europe. And this is connected to the previous question of economically sustainability of the innovations we are developing. We have to be smart, and we have to use machines and robots, which doesn't mean that we are ruling out completely workers, of course, but it's a different type of work, perhaps.
Thank you very much. Stefania.
Yes, and if I may, I think that another sector where AI will be very, very important is the development of materials. So not only the processing of raw materials, but AI as an enabler of for the development and design of new materials. So materials that are more performant or tailored to specific aims with specific properties. And I think this is something that will be relevant for many sectors, including the permanent magnets, where having AI assisting the development of the material, especially predictive AI that can point out specific procedure and specific engineering approaches that can improve the properties properties of the materials, or also contribute to rationalize the use of raw materials to achieve the same results, that would be massively important, and something that I am really looking forward to see happening.
Very well. So we can move now to the third question, that is about how do you picture mining and recycling in 2050? What standard technologies do you expect to be in use, and how do you think they will revolutionize mining and industrial operations compared to today's practices? So in summary, this is, I don't know if you remember that we had a vision about what was going to happen in the year 2000. Now we are asking you to say, what do you expect to see in 2050 in this field of mining and recycling? And I agree with Ana Maria that we are not very far. She mentioned 2030, that it's tomorrow, as you said, but 2050 is after tomorrow. So let's see. What are your views about this? And we are recording, so in 2050 we are going to compare. How visionaries you are. We are all together. So wants to start the first visionary?
Again, I'm gonna talk with the general global perspective of what I see of the future of mining and recycling. First, I will see autonomous and artificial intelligence driven operations, fully automatic mining fleet, vehicles, trucks, drills, smaller operation teams, remote mine management, that a couple of mines I saw in Chile last year, remotely operated. They don't have to go up to the mountains, more than 3,000 feet. They just operated in a town, everything, basically. I mean, the operations, the vehicles, trucks, drills. There is also a term in agriculture applied to mining, which is precision mining. Precision mining is the use of robotics, advanced sensors, drones, geospatial analytics, satellite imaging, etc., etc. So you really could inclusive inside leashing, note extract without extractive and processing without moving the rock. Also green energy, more use of hydrogen fuel cells. And finally, I would say the blockchain for mining traceability. It's very important, not only for Europe, for America, but also for countries in Latin America and Africa, in terms of knowing exactly the whole supply chain, the legality, the origin, and how you trace this to the end user.
Thank you very much. Very, very, very good vision. Let's see another view. Ana Maria, please.
I can talk about from the recycling perspective. I mean, it's quite a difficult, it's a complex issue. And I guess this is because the recycling rates are so low for some critical materials that are lost in the processing. Because, I mean, the recyclers, they receive a huge amounts and different types of different electronic and electric equipment. It's incredible. The amount, the variety, it's very difficult to have one solution that is going to handle all the different types of end-of-life products. And it's an utopia, in my opinion, to have this design for recycling. It's very difficult to push the the IT companies to have one design only is very complex. So maybe what I would see in my elderly house in 2050 is a kind of take-back system where the end-of-life product manufacturers will take back their products, develop dismantling machines that can tackle their special products, their specific products, and perhaps then they will push them to harmonize their products. So then their robotic cells and systems will be able to dismantle them at in a good way and in good efficiencies. So maybe this is the way to have a take-back systems where the end of life, where the product manufacturers will dismantle and then send to smelters, recyclers afterwards. Otherwise, it's very difficult to tackle the amount of end-of-life products that the recyclers are receiving per today. It's my opinion.
Yes, thank you very much. Anybody else wants to mention about the vision for the future?
Just to complete, because I don't want to repeat, an additional point is a low CO2 emissions industry, not only for the extraction, but also for the treatment of the mineral raw materials and also the recycling. I think that this is a key point, and we are working in the good direction from many perspectives, but this is something that has to be achieved in order to be ready to deliver what is expected from us.
Yes. Thank you very much. So now my last question is the following one. If you'd like to highlight something else about your project, so I think that you addressed already all the relevant points and the relevant aspects and elements that you are following and that you are addressing in your projects. But is there something that you want to say to finalize this event? It's now the time. It's now or never. So
maybe I can say something, if I may, or okay. It's not only connected to passenger, but it's rather connected to the cluster. It's a quick acknowledgement that I want to do to the Sustainable Critical Raw Materials for Europe cluster that for the friends is known as CRM4EU. So this clustering activity is now bringing together 16 EU-funded projects. And every one of these projects through different approaches with different specific application with different methodology is working towards the same goal, that is making Europe more resilient and more sustainable in the supply of critical raw materials. And so I'm very happy to see that this event was organized under the umbrella of the cluster. A special mention to passenger that initially started this effort to bring together different stakeholders and different projects that little by little understood the power of networking, like the opportunities that can come from clustering. And so I'm really grateful for this and really happy that this event was organized and looking forward for other similar events to happen.
thank you very much.
Maybe I'll jump with some conclusions on the field of sustainability and green energy from Rotate. Of course, our target is minimize emission, minimize the environmental footprints, looking toward zero emissions, of course, but also we don't address that specifically on this project, but maybe it will be a result in the coming future, to have a nature positive mining, which is go a little bit further from minimization of residues and environmental impacts, and have something else for nature.
Thank you very much, Carlos. Anything else that you want to
If
say
I
that
may, I
please?
would like to say that this kind of project are a great opportunity for Europe. Of course, we are, let's say, responsible to manage the project with success, but it's a big responsibility because the project are not for us, they are for European citizens. And they are a big opportunity because we have to say that the majority of the raw materials industry is integrated by small companies, SMEs, not only for the extractive part, but the treatment and the recycling, etc. And thanks to this kind of project, we can make big steps to deliver tools to help these companies that alone, they will never get the opportunity to achieve the improvement that are expected from them. So for us, I think that it's important to have this kind of opportunity to lead the project, to make the industries, the sectors to move forward in the direction that is expected. And this is something that in our particular case move us to apply to this project. We need to change things, and for that we need the support of the Commission.
Thank you very much, Cesar. And I think that we don't have any other intervention. So it's time now to close the session. But before, of course, I would like, I'm not going to repeat the aspects that were mentioned here in these discussions, because they were many. But of course, I would like to just to make some references to, for example, the sustainability, the environmental impact that is present in your minds and in your projects. So you know very well the field, the reality. Also the use of artificial intelligence and other emerging technologies, that you are fully aware that this will be the future, that it's important to communicate and to involve the citizens from the very beginning of the projects, in case of projects in the field, of course. And one aspect that I really like very much is these synergies, that you are in contact, that we are putting together dozens of entities, hundreds of people discussing this subject, and taking care of the future of Europe, because this is at the end what we get as an outcomes of all these projects all together, is to look forward how we are going to do the way for the future. So I'm very, very proud, because I was the coordinator of some of these topics at the time of the evaluation of the proposals. Of course, everything with the contribution of external experts that we contract for the evaluation of the proposals. I'm very, very proud that you are achieving such amazing results. As I said, 2 projects will finish this year, another 2 next year, and the last one in 2028. I hope that you are involved in other projects. We have calls every year, as you know. And my message on behalf of HaDEA is to thank you as coordinators and representatives of the projects, and to extend this compliment to your teams, because it is really great when we see that things are going well. And of course, I could not forget my colleagues, because I am the project advisor of one of the projects, currently the Eximin CRM. Before, I was the project advisor of Rotate, but together with me, that is Floriana Lamarca, Marco Kakanowski, Dimitrios Biliris and Traian Branza, my colleagues in my sector of the raw materials in the unit of industry in HaDEA. We are all working on this, so running projects, coordinating and advising when you need our advice and our support, taking the messages from you to transmit to our parent DG, that is DigiGrow, about future developments, about difficulties, about challenges. So everything that is important that we are aware of, and they have to transmit to the policymakers as well, of course. And a big thank for inviting HaDEA, me, for this event. And of course, our technicians, they are great. They are doing a great job, I'm sure. They are behind the camera, but they are here in the room. Four fantastic technicians. They are the future of... so they will see the record in 2050 and they will check our expectations. And that's all. So I would like also to thank the audience, the remote audience, and of course the panelists. The fact that you are in my second city, in my second country, here in Belgium, and you are lucky with the weather, because the weather is really unusual. It is even better that in other countries that usually have better weather. So it was, I think, a very interesting event, and thank you again for organizing.
Thank you.
It was great.
Thank you for being with us.
Thank you.
Thank you.